Good morning to everyone. Myself, I am G Charan from Triple E branch. Today's my tech talk topic on electromagnetic fields is electromagnetism without fields from rested through Ampere to Weber historical corner. Electromagnetism is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields, and it is responsible for electromagnetic radiation such as light. It is one of the four fundamental interactions, commonly called forces, in nature together with the strong interaction. The weak interaction force and electromagnetic force are unfilled as a single electroweak force. Electromagnetic phenomena are defined in terms of the electromagnetic force, sometimes called the Lorentz force, which includes both electricity and magnetism as different manifestations of the same phenomenon. The electromagnetic force plays a major role in determining the internal properties of most objects controlled in daily life. The electromagnetic attraction between atomic nuclei and their orbital electrons hold atoms together. Electromagnetic forces are responsible for the chemical bonds between atoms which create molecules and intermolecular force. The electromagnetic force governs all chemical processes which arise from interaction between the electrons of neighboring atoms. Electromagnetism is very widely used in modern technology. An electromagnetic theory is the basis of electric power engineering and electronics, including digital technology. There are numerous mathematical descriptions of the electromagnetic field is there. Mostly prominently, Maxwell's equation describes how electric and magnetic fields are generated and altered by each other by charges and currents. The theoretical implications of electromagnetism, particularly the establishment of the speed of light based on properties of the medium of propagation, permeably and permittably led to the development of special relativity by Albert Einstein in 1905. In 1800, the invention of the electric pile by Alessandro Volta started a revolution that gave rise to a new research field, galvanism. Nth occasions of 200th anniversary of Oersted discovery of the magnetic effects of electric currents. This article summarizes the main stages of the development of electromagnetism before Maxwell's from Oersted experiments through Ampere's developments of electrodynamics and Faraday's discovery of electromagnetic induction. Up to the development of Weber's electrodynamics, the emphasis is on the conceptual evaluation that led. At the beginning of the 19th century, electricity and magnetism were well established fields of research. For a general overview of the development electromagnetism in the 19th century, relying on Coulomb's result in 1812, Simon's Denis Poisson's 1781 to 1840 accomplished a mathematical formation of the oldest and best understood part, frictional electricity, namely electrostatics as it will. be denominated by ampere. The analogous formations of magnetism was completed by Poisson 10 years later. Well, after Ampere's formulations of his alternative electrodynamic interpretation of the magnetic interaction, in 1800 the invention of the electric pile by Alessandro Watt started a revolution that gave rise to a new research field. Galvanism, after a few years, the impact of the new device had extended well beyond physics from physiology and medicine to chemistry. On the evening of 21 April 1820, Christian Ørsted, famous professor at the University of Copenhagen and secretary of the Royal Danish Society of Science, while giving a lecture of his course on electricity, galvanism, and magnetism, performed an experiment that would modify the very nature of these scientific fields. The lecture and the experiment were briefly described by Oersted in a paper published the following year, where the word electromagnetism appears for the first time. I call attention to the variations of the magnetic needle during a thunderstorm. At the same time, I set forth the conjecture that an electric discharge could act on a magnetic needle placed outside the galvanic circuit. I then resolved to make the experiment since I expected the greatest effect from a discharge associated with the incandescence. I interested in the circuit a very fine platinum wire above the place where the needle was located. The effect, namely deflection of the needle, was certainly unmistakable, but still it is seemed to be so confused that I postponed further investigation to a time when I hoped to have more sure. Electromotive force EMF is equal to the terminal potential difference when no current flows. EMF and terminal potential difference we are both measured in volts. However, they are not the same thing. EMF E is the amount of energy provided by the battery to each coulomb of charge Q passing through it. The historical electromagnetic theory begins with ancient measures to understand atmospheric electricity. In particular, lightning, people then had little understanding of electricity and were unable to explain the phenomena scientifically. Understanding into the nature of electricity grew throughout the 18th and 19th centuries through the work of research such as Coulomb, Ampere, Faraday, and Maxwell. In the 19th century, it had become clear that electricity and magnetism were related and their theories were unfilled. Wherever changes are in motion, electric current results, and magnetism field is electric charge, whereas that of magnetic field is electric current change in charge in motion. As of the 2019 redefinition of the SI base units, the ampere is defined by fixing the elementary charge to be exactly, which means an ampere is an electrical current equivalent to elementary charges moving over 1.602 seconds of 6.241 into 1018. Elementary charges moving in a second prior to the redefinitions of the ampere was defined as the current that would need to be passed through two parallel wires 1 meter apart to produce a magnetic force of 2 into 10 to the minus newtons per meter. For a more accessible and less technical introduction to the topic, see Introduction to Electromagnetism. Electromagnetic redirects here. Electromagnetics may also refer to the use of electromagnet. Electromagnetic force redirects here for the force excited on particles by electromagnetic field. See Lawton's force. Thank you.